Hello students, how are you? I think you are fine. Okay, in my last class of correlation and regression, I have discussed about the bivariate data, what is correlation, types of correlation, and the measures of correlation, that is coefficient of correlation given by Carl Pearson. And we have discussed the types of simple correlation. You know, there are 5 types of simple correlation: partial positive correlation, perfect positive correlation, perfect negative correlation, partial negative correlation, and zero correlation. Okay, today I will discuss the second class of your chapter 6, correlation or regression. So now we will discuss the scatter diagram. Scatter diagram, the values of some pairs are given. If the values of some pairs are given, then for each pair you will get 1 point. And if you put this on the graph paper, then whole things will be a scatter diagram. Let us go to our topics. Scatter diagram, when two related variables plotted in a graph paper in the form of dots, is called scatter diagram. In a scatter diagram, there are two axes, x-axis and y-axis. For each pair of x and y, each pair of x and y, we put dots and thus obtain as many points as the number of observations are given. By looking at the scatter of the various points, we may confirm an idea as whether the variables are related or not. If I give you an example, then this is very easy for you. Here, the advertisement cost of sales of a company are given. These are the advertisement cost of a company in thousand. That is 10,000, 13,000, 16,000 like this. And this is the sales of SE, say SE, 8 pieces, 10 pieces, 12 pieces, 20 pieces like this. Okay, this is X and this one is Y. If we put here X in X-axis or horizontal and Y is Y-axis or vertical, first of all you will just take the scale. You have smallest square here, 5 smallest square. So 1 smallest square equal to 2 unit in both the axes. 1 smallest square equal to 2 unit. So here it is 10, it is 20, it is 30, it is 40. 10, 20, 30, 40. Okay, first is 10. X is 10, Y is 8. 8 is this one is a point. This is a dot. Okay, then first is 13. 13, X is 13. That is here 13. And Y is 10. This is 10. X is 16. X is 16. Y is 12. 12. 10, 12. Each smallest square equal to 2 unit. They put a dot. Then 16, 12. X equal to 16. 10, 12, 14, 16. X is 16. Y is 12. Here is 12. Okay. The last one, X is 50. X is 50. Y is 30. Y is 30 here. Okay. This one is. So by this way we will get the dots. For each pair we will get 1 dot. Each pair will get 1 dot. Each pair will get this. This pair will get this dot. This one, this dot. Okay. And this one is this dot. Okay. 50 and 30. This is 30. This dot. So this may not in the same straight line, maybe in same straight line, lie on the same straight line. Okay, this whole thing is called scatter diagram. Understood the scatter diagram? In axis you will put the value of x, and y axis you will put the value of y, and for each pair you will get a dot, and this whole thing is called the scatter diagram. The line is not matter. You can draw a line or you cannot draw the line. You will draw the line either to test whether the dots are in same straight line or not. You just to justify this, you will put the line. No need to put the line in for describing the scatter diagram. Just you put the line to test it. By scatter diagram, we can describe the nature of correlation also. By scatter diagram, we can describe the nature of correlation. As I told or discussed in my previous class, that simple correlation are 5 types, like perfect positive correlation, partial positive correlation, perfect negative correlation, partial negative correlation, and zero correlation. These 5 types are also be described by the help of scatter diagram. So you have already learned the scatter diagram. So now we are describing perfect positive correlation by the scatter diagram. Here a scatter diagram is given and 4 pairs are given, plotted. When all the plotted points of a scatter diagram lie on the same straight line, all the plotted points lie on the same straight line, falling upward. This is the upward line. Lower left corner to upper left corner, upper right corner, lower to upper, upward, lower left corner, upper right corner. This is the left side, this is the right side. Lower left corner to upper right corner, and upward from here to here, upward. If the line is go to the upward, from lower to right, from lower to upper, left to right, lower to upper, that is upward line. When all the plotted points of scatter diagram lie on the same straight line, what about the line? Line would be upward line. From where to where? Left corner to right corner. Then this is called perfect positive correlation. Mind it, here all the points plotted on the same straight line are in this case are equal to 1. Now partial positive correlation. Here also the line also upward line. From left to right, this also same. Left to right, same. Upward line, this also same, but the points are not lie on the same straight line. Not same straight line. There are so many points from the outside the lines. This is partial positive correlation. So what is said? When all the plotted points of scatter diagram do not lie on the same straight line, falling upward lower left corner to upper right corner, then correlation is known as partial positive correlation. Here partial positive correlation is, that is 0 to 1, 0 to plus 1. Okay. Now perfect negative correlation. When all the plotted points of scatter diagram lie on the same straight line, again same straight line, but the direction of the line is not same. Here falling downward, okay, from upper to left, upper left corner to lower right corner, upper left corner to lower right corner, then the correlation is known as perfect negativity correlation. Here, all the points lie on the same straight line, but direction of the line is downward from left to right. This is downward, and the points are lie on the same straight line. So it is perfect negativity correlation. In this case, r equal to -1. Then partial negativity correlation. The difference between perfect and partial negative correlation: here all the points are lie on the same straight line, here the points are not lie on the same straight line. Other all these things are same. While all the plotted points of scatter diagram do not lie on the same straight line, falling downward from the upper left corner to lower right corner, then the correlation is known as perfect negative correlation. Here the points are not lie on the same straight line. Points are not lie on the same straight line, and the direction of the line is downward. Now, zero correlation. Zero correlation is when plotted points on scattered diagram fall on straight line like parallel to x-axis or y-axis or without any discipline manner, then the diagram indicates no correlation or zero correlation. It may be a straight line like this, maybe straight line like this, or any manner, any do not mention any discipline or any manner. So that I have discussed earlier. Like then the correlation is called zero correlation. Now we will discuss the properties of correlation and coefficient. Properties of coefficient of correlation. Properties of coefficient of correlation are: coefficient of correlation is a pure number. Coefficient of correlation is a pure number, that is, it has no unit. You know the formula that I have discussed earlier. Coefficient of correlation are equal to summation xi minus x bar y minus y bar root over summation xi minus x bar square y minus y bar square. That is, this is the ratio. In the numerator you have x and y, denominator also x and y. So since it is a ratio, so unit will be deducted, unit will be cut. So there is no unit. That is, coefficient of correlation has no unit. So it is a pure number. Coefficient of correlation is independent of change of origin and scale. If you change the origin A and C in case of x, and y equal to y minus b by h, that is origin and scale, if you change, that is, it is independent. Nothing else, formula will be same, that is rxy equal to rub. You just remember this. Coefficient of correlation of two independent variable is 0. That's if there is no relation, that is, they are independent. In this case, coefficient of correlation are equal to 0. Coefficient of correlation is symmetrical with respect to x and y. That is, coefficient of relation between x and y and x, both are same. That is, rxy equal to ryx. This is very important. I have told earlier also, coefficient of correlation lies between -1 to +1. If we get more than 1 or less than -1, you will understand that your math is wrong. So coefficient of correlation lies between -1 to +1. Now the coefficient of correlation R is the geometric mean between two regression coefficients. I will discuss in our next class regression coefficient. Regression coefficient are two regression coefficients, byx and bxy. So geometric mean of two regression coefficient bxy and byx is equal to the coefficient of correlation R. The arithmetic mean of two regression coefficient cannot be smaller than correlation coefficient. that is arithmetic mean of two regression coefficient byx plus byxy divided by 2. This is the arithmetic mean. Not smaller than, I mean greater than or equal r. So byx plus bxy divided by 2 greater than or equal to r. Coefficient of correlation depend on the values of the variable. Variable is depend on the variable. It is affected by the highest value of the variables. Okay, have you understood? Okay. Now we'll discuss how to comment if some values of r is given. Usually you can get this type of question in question B. In question B of descriptive question you can get if r equal to 1 explain, if r equal to minus 1 explain, okay, r equal to 0 explain, like this. So if r equal to 1, what will you comment? If r equal to 1, it means that there is perfect positive correlation between the variables. That is, the direction are same and the change of values of the variable are same. Direction are same, that is, one is increase, other also increase, one is decrease, other also decrease, and the amount of change are same. That is, it is r equal to 1 means perfect positive correlation. R equal to minus 1, this is perfect negative correlation between the variable. That is, the direction of the variable are opposite. That is, if one is increase, other is decrease, one is decrease, other is increase, and the change of the values of the variable are same. Perfect negative correlation, that is r equal to minus 1. R equal to 0, that is 0 correlation, there is no relation between the variables. R equal to 0.8 means that there is a partial positive correlation, that is greater than 0, less than 1. Greater than 0, less than 1. 0.8 is greater than 0, less than 1. That is partial positive correlation between the variable. That is, the change of the values of the variable are in the same direction but not equal. Okay. Now r is greater than 1. We have known it earlier that the value of r lies between minus 1 to plus 1. So here r is greater than 1. How it possible? We have told earlier that r is lies between minus 1 to plus 1, and here it is greater than 1. So it is not possible. The minimum and maximum value of correlation coefficient is respectively minus 1 to plus 1. So the situation r is greater than 1 is impossible. R equal to 2, R equal to 3, or R equal to 5, R equal to minus 2, R equal to minus 9, whatever it is, same comment, it is impossible because as it is greater than 1. Now r square equal to 0.85. What does it mean? It means that 85% changes of the dependent variable. Changes of the dependent variable effect on the change of independent variable. The change which is change only 85% is dependent variable effect on the change of independent variable. In other way, we can say that due to change of the values of the independent variable, dependent variable change 85%. That is, for independent variable, dependent variable change 85%. This is r equal to 0.85. Anything else may be given 0.75, 0.68, 0.92, anything like you will comment according to your question. Okay. Now the use of coefficient of correlation. Coefficient of correlation represent the direction of the variable. If r is greater than 0, then the direction is same. If r is less than 0, then the direction of the variable are opposite. The numerical value of r represents the degree of relation between the variables. Between two variables, if one is independent and the other is dependent, then the coefficient of correlation measures the percentage of change of the dependent variable due to independent variable. There is use of coefficient of correlation in economics, use in business, use in other activities, social activities also. Okay. Now covariance. Covariance is the sum of the product of the difference of the values from their arithmetic mean is divided by the number of the pair of observation. Let n pair of values of the variable x and y be x1, y1, x2, y2, x3, y3, xn, yn. Now how many pairs are there? N pairs. And the arithmetic mean of x be x bar and y be y bar. Then covariance of xy is denoted by COV, cov xy, covariance of xy. Covariance of xy equal to summation xi minus x bar y minus y bar divided by n. If we simplify it, then you will get summation of xy, that is sum product of xy, minus summation of x into summation of y divided by n, and whole divided by n. That is numerator is summation xy minus summation x summation y by n divided by n. This n is this. Okay, summation xy minus summation x summation y by n divided by n. Xy will be given and n is the how many pair are there. So covariance xy equal to this or this. For solving maths, this is very easy to solve your maths. Okay, you can solve by this way also, or you can solve both way. We have to know, but this one is the easiest way. Thank you. Okay students, I think you have understood everything. I discuss very simple way your chapters, but if you arise any problem, any kind of confusion, you can contact me in my messenger or you can phone me. Okay, I will make it easy, very simple way. Okay, hope you will stay home and safe. Thank you.